This video will focus on introducing you math intervention research. We start with concepts related to this, then followed by intervention study designs, and finally talking about the effectiveness of interventions. When we talk about intervention, we may mean the actual intervention research, or then intervention programs, which is often first used in intervention research studies and after proven to be effective, used, for example, at schools. Intervention means a planned modification of the environment made for the purpose of altering behavior in a pre-specified way. For example, we may use a specific math intervention program for this purpose. It's a specific program, for example, for training multiplication, for a specific group, for example, for low-performing students in multiplication, to be conducted in a specified time frame, for example, in 8 weeks, and with a specified intensity, for example, twice a week for 30 minutes. The behavior we want to alter is the performance in multiplication skills. In special education, intervention may mean that we try to prevent difficulties, for example, math difficulties. These interventions then often take place in early childhood and in the beginning of schooling. On the other hand, intervention may mean diminishing difficulties. For example, we try to provide targeted interventions for those students who already have been identified as having math difficulties. Here's an example. We know that counting skills measured in kindergarten predict performance in later arithmetic skills. Therefore, we will need and try to identify all those children who struggle in their counting skills. After we have identified these children, we need to provide them with counting skills intervention so that they would learn better counting and would try to catch their typically performing peers in counting skills. What happens if we do not provide intervention for these low-performing children? Research shows that in general, along the school years, these children continue to lag behind their typically developing peers in different math learning, and the gap even gets wider. What we aim with interventions is that this achievement gap could be reduced so that the low-performing children ideally would catch their peers, for example, in counting skills. This is quite typical intervention study design. Before the intervention phase starts, the participating students are measured, often with a variety of different tests, both math-related and more domain general ones, such as nonverbal reasoning or working memory. It is important that the measures which are used are of good quality and reliable. Then part of the participants will receive intervention, so they are in the intervention group, and the other ones will serve as controls, receiving either some other intervention program or only following the typical math instruction. The conductor of the intervention program can be, for example, some from the research group or a teacher. The conductor follows carefully the program instructions, which also defines how many times intervention is given. Often some extra resources might be needed, for example at school, the person who is conducting the intervention, and also materials for the actual intervention program. Then after the intervention phase at post-test, the students often do the same math tests as before the intervention phase, so that we can compare the test results from 2 time points and see if the results are better at post-test, meaning that if the intervention was indeed effective to boost children's math skills or not. Follow-up follows sometime after the post-test. Then again the same math tests are given to see if the intervention effect has remained after the intervention ended. Different groups are most often included in intervention studies. First of all, if the study is a randomized controlled trial, then the participants are randomly chosen into different groups. If the studies are quasi-experimental, then it might be that some of the classrooms are decided to be in intervention group for practical reasons, for example. Most often we have passive and active control group in addition to the target intervention group. For example, as in the pictures, we might have the intervention group consisting of low-performing children that receives our math intervention program. Then we might have a passive control group, also with low math skills, but they do not get any intervention. Then we might have an active control group, again low performing children in math, but they, for example, receive another type of math intervention, or maybe a reading intervention. And then to be able to see if the low performing children catch up their peers after the intervention, then a group of typically performing children is also included in the study. Often standardized tests are preferred over researcher-developed tests, as they seem to be more reliable. Sometimes the research, however, need to make new tests if there are not good or suitable ones available. In addition to achievement tests, such as math tests, the researchers often collect some other data as well. For example, using different types of questionnaires, they do observations or collect logbooks in order to see if the intervention program is conducted as it should have been. Also, teachers and children may be interviewed. In general, a rich dataset is produced from intervention studies. Fidelity means that researcher wants to know if the teachers, for example, are doing what is expected to do during the intervention. They, for example, may ask the teachers to fill in logbooks, or they may go to the classrooms and observe teaching sessions and do some video recordings. If it's found that the research are doing something else than what was instructed in the intervention program guidelines, then this often affects the interpretation of the results, and we may not be sure was it really the intervention that made a difference or something else. This is an example from a logbook. The researchers here were interested in finding out how much time was used for each session and if there were students who were not present in intervention sessions as planned. Here it's also asked which of the tasks were done and how the children felt the tasks like. For example, were those too difficult or how interesting the tasks were. All these asked questions give researchers evidence of how the intervention was carried out in practice. When talking about if our intervention program in the end was effective or not, we can use some general guidelines for this to begin. The basic assumption would be that if the intervention group performs better after the intervention than the control group, then we can say that the intervention program was effective. The effect is even better if these differences are still shown in the follow-up. The ideal situation would be that the low-performing intervention group catches the typically performing children after the intervention ends, and maybe these learned skills also transfer to some other skills. In many intervention articles, you will find also so-called effect size for the intervention. The larger the positive number, the better effect the intervention has compared to the control group. If the effect size is negative, then the control group has done better. There are two families of effect sizes, which you may see in the articles, namely the ones from the D family, and those values indicate the standardized mean difference between the groups. And then the other one is correlation. From the table, you will see that the cutoff values, for example, for medium effect, are different depending if you have used standardized mean difference or correlation. Effect sizes allow us to compare which of the different math programs are the best. These comparisons can be seen, for example, on reviews or meta-analysis. The website of What Works Clearinghouse is an example where you can find information about the effectiveness of different math intervention programs compared to each other.